we'll just wait for. Oh.
Hello, this is Eugene. Hi.
Hi, Eugene.
Hi, is this Anu?
Yeah, hi, this is Anu, yeah.
I'm good. Did Payam make it?
Yeah.
Yeah, I'm here. Hello.
Oh, good. Good to hear from you. All right, good. Excellent. Okay, so I'll just stay quiet. Payam has pretty much got everything under control, I think.
Okay, so I guess we will start probably a couple of minutes later, just because.
Sounds good. So I'll just mute myself, and I'll just unmute if I have anything to add, which not sure if it's needed. Okay, thank you. So Payam, sorry, did you make it to Houston? Okay.
Yeah, it's good.
No trouble with the air,
No,
travel this time? Oh, good. All right.
Thank you.
Excellent. Sure. Oh, so I see that we literally just now got an invitation to the all hands meeting in California.
Okay, that's going to be in the beginning of August, I think.
Sorry?
It's the beginning of August?
Yes, August 7th.
Yeah.
All right, so I'll ask later offline, I suppose, which ones of us should attend it. And, yeah, okay. Because the way it was phrased, it says if you're interested in attending, it's not clear if I thought it was required, but I don't know if it's changed.
Oh, okay, but I think maybe Elizabeth, who's also on the call, I see her on there right now. She could probably.
Okay, so I'll wait for her to mention it, I suppose, and ask questions if she doesn't, answer them in advance.
Sure, we can talk about it.
Okay, it's not critical. I'm sure they'll get more information later. Okay, thank you.
No worries. So I think I see most of the people that we expect on the call. Hi everybody. In the room here I have Trevor, Kirk, Firat, Payam, and Shaoling. And on the call I have Elizabeth, Eugene, Huni, Ian, Jeff, Yuling, Nansu. Did I miss anybody? So if not, we'll move forward. Ergen is also here. Actually, today we'll have a presentation by Payam. He's going to talk about the system that they submitted for the BioCaddy IR challenge. Payam is visiting us here in Houston. He's going to be here for about 3 days. So he's already started working with Shaoling to figure out how to integrate some of their features into DataMet. So we'll anyways hear more about the work that they did. And Eugene is the PI from Emory, and Payam is in Eugene's lab. I'm sure they'll have a better introduction than what I just gave, but I just wanted to let you know. And besides that, on the agenda, if time permits, then we could go over some of the features for DataMet version 3 release and get updates from all the team members. So in terms of the action items right now, what we have is Alejandra has set up on GitHub a repository called RAO. This is Resource Annotation Ontology. So I think they've compiled a couple of ontologies to address the different resources that we want to annotate. And please review this, and maybe we can provide some feedback. Also, for the schema.org annotations that Firat was working on, thanks to everybody for testing. I know that we had some feedback which is useful.
Yes, with the double quotas.
Yeah.
BP
So the schema.org annotations is now on the production server. So I think we're done with that. And with that, I'll let Payam
Thank you.
handle his presentation.
So, hello everyone, I'm Payam. I'm a first year PhD student. My research study is information retrieval, and I'm pleased to work with Professor Einstein at his IRI. Thank you. So, will you change by mouse?
Click here? No, it's not.
Okay, thank you. So first, I provide a very quick overview of the challenge. So I think there is no need to introduce the challenge. So I will skip it very fast. Then I talk about our architecture, our proposed architecture, and then I will discuss our design details and key decisions that we made, and then I report our experiments and results, and then finally I conclude the presentation. So we were happy to work on your data set. It almost had 800K biomedical data set descriptions, which were crawled from 20 different web domains. Each document had 4 fields: document number, title, repository, and metadata. The training phase was, in the training phase we were given 6 queries, and in the testing phase we were given 15 queries, and the evaluation metric was NDCG, modified NDCG, inferred NDCG. So the challenges that we were faced with was first the query intent. The query intents were rather different from ad hoc information retrieval challenges. They were mostly transactional, which is somehow looking for an information which helps indirectly to solve a problem, in contrast to regular informational queries, which usually you're satisfied with the reading of the document. And our second challenge was a high query and document mismatch, which we tried to address using query expansion. And the third challenge was a small number of queries, unusually small number of queries. Usually we were given 50 queries, but in this challenge, due to very high cost of labeling, we were given 6 queries. So we needed to find a way to actually address these issues. So this was animation, but it's like
I'm sorry.
No,
I think the PDF conversion.
So here, in the first step, in the initial retrieval step, we actually run the initial query against the index, and we expect to have top documents which we expect to have a ranked list of documents which usually has a high precision due to our retrieval model. In the second step, we try to deal with the high query document mismatch through query reformulation and expansion. And in the third step, we try to use actually learning to rank framework, which helps us to address the query drift of the second step. So the main idea behind this architecture is we expect to have a high precision in the first step. Then we try to address the query document mismatch in the second step, which usually improves recall and usually decreases in precision. And in the third step, we expect to re-rank the top document and again improve the precision. So just to quickly give you some idea about the architecture, all the connections are function calls in the operating system except calling the LTR module, which is the operating system call. We used Wikipedia and NCBI data sets through Google vertical search. Obviously, we're not suggesting you to use Google. Our idea was to explore if we can actually extract useful information in textual data. So if we find this useful, we could actually build our offline data sets and search engines to search through textual data for extracting useful keywords. For HGNC, we use offline search, and for cake databases, data set, we use its API search. So we use Lucene for indexing and retrieval as an indexing and retrieval tool. We use RankLib for learning to rank framework, and we use TrackEval to evaluate performance. So in the indexing phase, we actually stored 3 searchable index fields: title, metadata, and dataset info. We're already familiar with title and metadata. We just ran a simple preprocessing and removed the repeated tags in this field. As our third new dataset, new searchable field, we manually collected some information on the web about web domains. So the intuition was maybe the admins of those data sets provided some useful information on their website. So we try to explore this hypothesis. As a retrieval model, we use BM25. So it's a probabilistic model which tries to estimate the probability of the relevance of a document to query given the query and the document. So this model has 2 parameters, K1 and B. K1 is for calibrating term frequency, and B for calibrating document length normalization. So our idea here was to actually do separate field search over all the document fields. So we didn't actually store all the fields in a single large mega field. We did search over all the 3 fields separately, and we try to understand which actually field is more important than the other ones. So as expansion models, we used 3 different expansion models. The first one is blind relevance feedback. In this simple method, it assumes that the top K retrieved documents are relevant, and it tries to extract useful information from those documents. So it tries to relocate the original query in the hope of exploring the neighborhood of those relevant retrieved documents. So as our second expansion method, we used as I discussed quickly earlier, we used 4 different data sets: NCBI and Wikipedia through vertical search, Cake through API, and HGNC through offline search. So we use external search conditioned on, external query expansion conditioned on observing those extra terms in the top document. So the idea is to avoid query drift through actually observing those new terms in the top document. And as our third query reformulation method, we used query term weighting. So BioCADI queries were verbose queries. Their length was almost 16 terms per query, which is different from the 3 terms per query of regular web search. So the common technique in IR is to use keyword selection. We use weighted information gain, or WIG, proposed in recent years by Grootcraft and his lab. So the idea behind this method is to compute the information observed in the top documents. So if for a specific term the information observed in the top document is higher than all over the collection, that term gets a higher weight. So this way we could detect actually more important terms in a query. Here is some examples. For example, in query number 3, you can see that the keyword detection algorithm successfully detected the keywords. So So those terms which appear in brackets, those are terms added by our external expansion method, and the rest of the keywords are added by internal or blind relevant feedback method. You can see that we almost have 100% improvement in some queries. We also have a small degree of increasing the performance through query drift. So as our third step in our architecture, we use LTR machine learning framework, which is a framework to actually find the optimal combination of features extracted for the pair of queries and documents. For example, one of the well-known methods is SVM rank, which is a variation of SVM classifier. It tries to map the problem of ranking to classification through defining pairs of sorted documents. So in this method, we actually tried a bunch of these methods. We finally ended up with using MART, which is a method which is built upon boosting paradigm and regression trees. So what you do is simply you design a feature vector for the pair of document and query pairs, and then you feed top k of these feature vectors into your model, and model tries to find the best combination of features, and next time that you want to use it in the real world, the model uses its previous predictions and uses those combination of features to re-rank the new queries. So here is what we use as a feature vector for in our model. We use 8 groups of different features. The first 6 groups, these are in green column, are group numbers. The first 6 groups are well-known features which are used by the community: BM25, Unigram TFs, Unigram IDFs, and bigrams. The last 2 actually features are our proposed features, which try to leverage the position of relevant query terms in a document, and the second one, or the 8th one, is the method, which is a feature which tries to capture the size of the web domain which we downloaded the dataset from. So we expect to get to assign a higher weight to those datasets which are downloaded from a larger web domains. So in our model, we had a bunch of parameters to train.
Sorry, this is Eugene from Remote. Payam, I think one of the interesting things that you did was to add metadata, not just the size of the web domain, but some description of what sort of the database is supposed to have, right, which you extracted from the website.
Yes.
Can you, I forget if you mentioned this before, maybe you should, it would be good to talk a little more about this, because I think it's useful.
Yes, maybe I skipped it quickly. So here, I described that we manually collected some metadata from the web domain that the datasets are located on. Here you can see that we also include BM25 metadata, which is row number 5, BM25 metadata. So in addition to regular titles and text, we also include these features for that metadata. So it helps us to overcome the high mismatch between the query and the document.
So the information is that for the same repository, it will be the same?
Yes.
Okay.
Exactly.
Okay.
Those data sets.
So for the data set in that repository, that BM25 method will be the same. So the same for each repository. Each repository is one value. Yeah, actually,
Oh,
it's like
okay,
that.
so it's not the data segment.
It's not. It's in repository
repository,
level.
okay.
Yeah.
So we had a bunch of features to train. We had here for BM25 two features, for document retrieval 3 features, for title, body, and that manually collected information, which just Eugene mentioned. We also had a top document for the first retrieval, and we also had top K-terms and their corresponding weight for the expansion process. So all of these features were actually trained through grid search. We use grid search to train these, actually to find the and calibrate these features. So you can see that for title, text, and metadata, we got 0.1, 0.3, and 0.5. You can see that the value of our manual features which we collected. And for the M25 parameters, you can see that for K1, which is term frequency, we got 0.8, which is almost a high number. And for the M25B feature, we got 0.7. These indicate that there are large data sets in the database which may not carry enough information. That's why we are getting BM25B equal to 0.7. So there are data sets which are quite long, and we need to normalize their weight. So after fixing those features, we try to actually train other parameters. So you can see that for external terms and their corresponding weights, we got relatively higher value to their corresponding actually internal values. You can see that, for example, for internal terms, we got 5 terms, and for external terms, we got 10 terms, which means using external terms for expansion gives us a higher performance. So here are the results. You can see that the highest jump is observed when we add term weighting after weak model for NDCG, and the highest precision is observed when we only use weak and blind relevance feedback. But the highest NDCG is observed when we add all the expansion methods. So for the learning to rank step, you can see that using this training data, learning to rank is not improving that much. Actually, it's decreasing the final performance. So our hypothesis was this problem is due to a few number of training queries. So we tried to do some kind of shallow labeling. We asked our biostat students to label the additional 30 queries that were provided. So for each query, we on average had almost 6 labels, which we were not even sure that those labels are accurate or not. On the other side, we had almost 1,000 labels for the official query. So you can see that by adding those very small, of course, relatively training data, which is of course noisy, we could improve the precision substantially, and also NDCG and MAP significantly. So the interesting observation here is what we did is almost similar to the implicit feedback which search engines are getting from user interface. So we hypothesized that if we have access to user implicit feedback, we could actually use these new techniques in information retrieval. So here you can see that using feature ablation, we try to extract the most important features. It is known that BM25 scores always are among the most effective features, and you can see that our new features, distance from start, which emphasizes the introduction of the document, is in the middle of the table, and domain weight is still higher than, for example, shared diagrams, which is very interesting. So we can assign a higher weight to those repositories which contain more data sets. So things which we tried but didn't work out. So first we tried multiple retrieval models, starting from VS models and different language models. We tried to use topic models to extract topic distributions from documents and extract some features to use in LTR. It didn't work. We tried different LTR models. We didn't observe any significant difference. We tried RankNet and coordinate. So conclusion. So our first conclusion is enriching the dataset description with the information provided by the information provided on repositories is helpful. Our second conclusion is the default parameter settings are not working. We observed that if we want to use default parameters in the methods, you wouldn't get a high performance. Our third conclusion is keyword detection is very important if researchers try to submit verbose queries to your system. Our fourth conclusion is using only text-based resources like Wikipedia or just simply crawling papers improves performance significantly. So there is no need in the at least beginning steps to have a very complicated structural knowledge base. And our fifth conclusion is LTR with this amount of training data is very prone to overfitting. And our final conclusion is having access to implicit feedback can be very helpful. So it can actually can be leveraged for further techniques in IR like learning to rank and other techniques. So thank you for your attention.
So are there any questions for Pam?
So this is Ian. I have one question. So can you go back to your conclusions slide?
Yes.
So on that first one, I mean, and what you've said about the additional information that's added, it's not really about the data set specifically, it's about the site in which it's come from. So
yes.
What's an example of the kind of information that's being obtained and how is it affecting the result? What's it learning and how is that resulting in it being more effective?
So what we did was manually collecting almost about pages from the website because
Give me an example of a website, of a data repository, and what additional information about that repository was obtained, and what does that tell? I mean, I'm going to say, what does that tell you? What does it tell the? I'm humanizing the algorithm, but
I understand. Yeah.
But what does it tell us that makes this more accurate?
So unfortunately, I don't have access to the examples, but I have the number and also the intuition. So our number is here in this table. You can see that the weight that we assign to that information is 0.5, which is significantly higher than even text and title. So I don't have right now. Maybe that could be a very useful experiment if I could just add this field and try to compare it with the text. But using this number, I can argue that since we are getting a higher number for this field in comparison to text and even title, so we can claim that this field is more important than the other ones. And our intuition is, I'm not expert in biostatistics and bioinformatics, but what I observed, because I personally collected the data, for example, there were some keywords in that, for example, description, which could have a really high weight in comparison to the normal query terms. For example, in the case of cancer, if a repository description contained this specific term, that term could match potentially to query term and get a higher weight. So, but I understand.
The repository description, what text is that? The about page for the repository?
So in each website you can find, for example, some pages on that website which tries to describe that content, right? I'm talking about those pages.
Okay. Yeah, like an about page or something. All right.
I hope, but you're right. If I had that specific experiment comparing only adding, just adding this feature and comparing with simply retrieval model of just text and title, that could be much better.
So the intuition. This is Eugene. So the intuition was to, in addition to specific repository information, to collect, like from the about page, the idea, we hope that, for example, the websites, and this is could be refined further, could be organized, for example, as sort of repository of human sort of genome data sets, or repository of, say, primate or mouse, or repository related to a particular disease, and of course, or a collection of repositories related to a particular domain. And we've seen some of this, but some larger domains or domains are more heterogeneous than others, so it could be further refined to sort of build sort of descriptions of the subsets of the sort of the websites or databases, right? Because again, sort of some of the repositories share common characteristics which are not explicitly stated in the repository description itself. I'm trying to get to the website to sort of provide a concrete example. Payam, do you remember any sort of examples of the descriptions that you included?
Actually, it was a long time ago that I collected those data. Sorry.
So when I'm searching on using your demo prototype, would that show me the metadata match itself?
Probably yes. In some
okay, so let me see.
Page there, you can. So I should have included that specific experiment. Sorry about that.
No, but this is very helpful. I'm sorry, it's not pre-computed. There's actually a search happening in real time. Which I haven't pre-computed, but
So I think still this table, I hope you can see it, is saying that the highest weight among those fields is assigned to that specific field, right?
So the reason, Ian, I assume, I'm not sure if you guys are collecting this information already. We found it useful. I think it might be, with a few more minutes of digging, we could probably give you a more concrete example. But you've seen what the about pages look like for those databases.
See, I'm trying to translate it to, trying to translate this to something real.
No,
querying, my interest might be, I think you mentioned, for example, we want to find genomic data, right? And that's my intent. And we know, for example, that certain kinds of repositories have genomic data in them. We know that that's the data types that they have. And we may even have that metadata about them. I mean, when we're assigning these data types to individual data sets, a lot of the time we're doing it on the basis that that we know what kind of data that there's in there. And so we already have that piece of metadata about a source. So if someone's articulating a query, you're saying, we're looking for genomic data on such and such a disease. This seems a very roundabout way of getting information that's kind of at our fingertips. And isn't there a better way of people articulating their intent in terms of the query they want to perform that's going to get them closer to what they're actually looking for?
Right. So I think the intuition was, or at least what we were trying to get at, is the more general information, the one that may not be stated in the actual repository. So I'm looking as an example of I searched for mouse sort of genome, and there is it points the data sets retrieved seem relevant, but it just says when you sort of click through to the actual data set landing page, it just gives information that it comes from an external source, right? But it doesn't actually say anything about, you have to dig further to figure out where exactly it's coming from. So there's sources, GEO or something like that. And inside GEO itself has its gene expression omnibus, right, which describes that it's includes data repositories for array and sequence-based data, and it's curated, and there's a few sort of other common characteristics of the repositories inside this GEO site. So that information, right, that it's curated, that it's sequence-based. Again, this is not the best description to use as an example, but that's the one I grabbed on the real time. That information is not actually contained in the individual repository, right, because that would be redundant. So we're trying to include that as, again, additional information about the kinds of repositories that come from this website. And the reason it would help, for example, terms like curated and array and sequence-based data are sort of obvious because every repository in that from that website contains those terms, or at least is like that. So those terms are never explicitly mentioned. but the user might actually want to get, say, curated data sets only, right? So this would help us match that kind of a query. So it may be a roundabout way to get it, but at the time when we were playing, the challenge data, this information did not exist in the sort of in the XML files.
Okay.
So I found something on my laptop. I don't know if it's updated. How can I transfer it to you? Can I email it to you, and then you?
Yeah, sure.
So let me see if I can find a more convincing example. Another one might be something like
just a quick question. The implicit feedback is basically what you would get, the information you would get from user tracking, right?
Yeah.
right. So our proposal or sort of plan was to if you could pass the click-through information, or I assume you're storing it somewhere in your logs. There's quite a few features that could be extracted that could be added to the learning to rank model, of course, and that could be allowing us to retrain the model without additional labeling. So the features would basically could be of two kinds. One's expressing, basically measuring whether the user is finding the page relevant or not, and they could be included as for the ranking of future queries for future results for similar queries that match the same keywords. Additionally, those click data, of course, can be transformed into labels to retrain the ranking model, and we've done quite a bit of work on this, and others have as well. So it's there's some pretty reasonable ways to take click-through data plus the time on the spent reading an article and some subsequent interactions to predict relevance to sort of reasonably accurately.
Right. I think we have started collecting, we have been collecting for the past couple of months the, user interaction data.
I think about 2 months. Yeah.
And you have user logs?
Log dash.
We do.
So that's great. So if that's something, if it's of interest, that's something that we would be interested in helping with is, again, sort of writing some scripts to or giving you some, it could be as well as little as just giving you some suggestions or papers on what people have done in the web search world to convert click data and that kind of signals into relevance labels. And again, the other way we could help is to actually extract features from this from the interaction logs that could be added into the ranking models. Right? Those are sort of two complementary ways that this data can be used, as you, of course, already thought about. So that's something we could help with as well.
So I sent this email. I'm not sure if it's the last version because I tried to update those metadata. So it's one of those things that I downloaded for rcsp.org web domain. So you can see that you can find some keywords. So the main idea is we try to actually deal with query document mismatch in a high level, not just in details. Of course, if the query is about details, this field may not help. But as Eugene said, if there are high level, like searching for humans or mice or other species, these fields might help if it's collected with discretion. So of course you can find some keywords, some text which is also irrelevant, but we assume that we could do it automatically. That's why I collected without any manually interfering the process.
So Ian, this is you asked for something real, so this is an example of the what we store for every repository that comes from, has been downloaded from this website, rcsb.org.
Mm-hmm.
And again, you're the expert, I assume, in the bioinformatics aspect of it. So I'm hoping you can identify some sort of useful keywords, and there's a bunch that look useful to me, but I'm not an expert in the domain. But they, for example, large biological molecules, right, for one thing, that are not necessarily mentioned in the specific description for each of the repositories, or for each of the data sets, I'm sorry.
So, right, I can see things that would maybe get you closer. I can see probably more irrelevant stuff, quite honestly, in here. It's talking about the founders of PDB and why that could throw one off as much as get one closer to what one's looking for.
Right.
It would be useful to see this alongside an example of a query. Which what data sets were retrieved as a result of having the knowledge of being able to associate this text with a data set?
So that's great. That's a great point. I think I know Payam did an ablation study, which means he turned off this feature, right, this part, and so we're sort of revising a manuscript based on this work. But anyway, so the short answer is yes, it's a great point. I'm sure it helps on average. I'm sure there are cases where adding this metadata degrades performance, and I know there are more cases where it helps. So Payam, I guess you don't have example prepared for this, but we certainly should include it in the manuscript, right? And you have done experiments with and without this metadata.
Yes, but I haven't included it in the slide. Sorry about that. So we have. Sorry, go on.
So I'm assuming that if a repository is more specific, you probably have better performance, right?
Exactly.
Versus a more generalized repository.
So and the part which was about the irrelevant information, so those parts will be discarded. IR methods have a specific feature which is called document length normalization. If the document is long, so it gets lower weight. But we can see, I still make the point that we can see that the weight which is assigned to this field has the highest weight in comparison to title, for example.
But Ian's point is good, that it would be nice, again, both in the paper and in the sort of future, to have sort of a concrete, like an example, right, of a query, just like you did for the query extension, to also show it, what happens if you don't include the metadata field.
Yeah.
Yeah, I think that's easy for you. I mean, you can, if you haven't done it already, it's probably pretty easy for you to do with your framework.
Yes, sure.
Okay, thank you. So,
well, presumably it was already done, I mean, as part of the evaluation. I mean, you came up with a different set of matches as a result of this, and it shows up in the numbers. It's a question of, I guess, whether we still have that data as to what matches there were when that metadata was used versus when it wasn't.
yeah, that's exactly that. No, we understood your point. It's just that we didn't prepare those examples, but that's a very good thing to include. Okay. It's just, we can't find it in real time. It's sort of data somewhere, that has to be
I just wondered if there was, off the top of your head, whether you can think of examples. So thanks for pulling up that page. But that gives a good example of, I mean, that was exactly the kind of metadata that I was thinking you were talking about. I mean,
right.
I imagine that is on the about page for PDB or some similar page about PDB, right?
I believe so. Payam is the one who did all the work, and I think that's where he got it from.
Yeah, they are from about pages mostly.
Right. But that part has to be. I mean, each repository or each sort of website has a slightly different location where they have this about page or description. So, but it only has to be done once when you ingest that data source to just find the corresponding about page. Our suggestion is to include it in your data.
I've just looked at the about page for PDB, and that's exactly where it comes from.
Right. It's just for some data sites, for some websites, this logical about page might be in a slightly different location. But yeah, I mean, it's a matter of just ingesting, doing it the first time when you ingest the data set.
So Jeff, do we already ingest some information about the repositories themselves, right?
Just basically the name and the base URL for the repository.
Oh, okay.
So the reason, so one thing, I guess you will probably have to wrap up soon. I guess what we want to know, or I would like to know, is what is the best way for us to help or move forward with integrating or somehow having Payam's work be useful to BioCaddy?
So I have discussed with Payam this morning. So for right now, we may want to adopt the BN25 and the bright relevance feedback method as well as the WIG. But for the learn to rank, maybe we don't have, before the release, the version 3 release, we don't have time for that. And also because the queries not that many, so it's over 15 problems. So I will work with Payam to learn how to setting that up and in the future we may, and then see the performance, we may integrate into data mesh.
And how much data do you think you need
For learning to rank?
Yeah.
I think Eugene should say that, but I know that learning to rank data sets are different from ad hoc data sets.
Yeah.
Yeah, they are much larger. Right, Eugene?
Yeah, so in the past, learning to rank starts to again, it really depends so much on the characteristics of the data set, but even with a few hundred queries, you start to see improvements. It really depends on the number of features, right, and the characteristics of the queries. I'm guessing since these are highly specialized queries, we don't actually we should not need that much data. By done that much, I'm thinking an order of 100 or so queries might be sufficient. And the second part I want to mention is if you already have 2 months worth of click data, that might even be sufficient to, again, train the learning to rank with the sort of noisy labels. So one thing may be helpful while Payam is physically on site is if you could take a look at the click logs, right? Not even the full interaction logs, but just to see which results, queries, and the results that were clicked versus skipped, right? So those are sort of the basic features used. That sort of would give us an idea, I think, if we have enough already data to retrain the learning to rank module.
We have that already, right?
I can give you the information about the log, then you can take a look to see. Is Divaka in the school?
Divakar is, I think, on holiday the whole of this week.
Okay.
But it would have been used. But we can put him in touch with
Right.
Payam and Eugene if they want to.
Yeah, so he developed that log.
That log,
Yeah.
yeah.
So that if any question maybe ask him.
Okay.
Yeah. By email maybe. Yeah, and in
Right.
future you can still
That's true.
contact him. Yeah.
Okay. Well, like I said, whatever, in any way that we can be helpful, we would love to see as much of our work incorporated into your system as makes sense, right, on your end without, obviously, as long as it helps performance and doesn't degrade it.
Mm-hmm.
Okay.
Were there any other questions, suggestions? No? So if not, then I think we'll finish a little early today. We have only 2 more minutes, so. Oh, thank you. So next week I'm going to be taking the day off, so I think Baz also is traveling, so probably I will be cancelling this meeting. And then the week after is July 4th.
Oh, really?
So we probably will meet again in 3 weeks' time. Thanks everybody for calling in.
Thank you. Thanks.
Thank you.
Bye.
Bye.
Bye, Neil.